Hello students, welcome to my lecture on computer graphics. I am Shravani Kundu, Assistant Professor, Department of Computer Science Engineering, Guru Nanak Institute of Technology. This is my lecture on the circle generation algorithm. This is part 2 of the circle generation algorithm lecture. In the previous lecture, I already discussed how to derive the decision parameter for the midpoint circle generation algorithm. Now in this lecture, I will show you how the decision parameter will be used to find out the points on the arc of the circle. So now see how the decision parameters are used to find out the points. So far we have discussed that the decision parameter for the k plus 1th iteration can be calculated like that. So pk, that is the decision parameter for the kth iteration, plus 2 into xk plus 1 plus yk plus 1 square minus yk square, yk plus 1 minus yk plus 1. So this is the decision parameter for the k plus 1th iteration. Okay. Now remember one thing. So this pk is the decision parameter for kth iteration. Okay. So being at kth iteration, we will find out the decision parameter for the next iteration. Now, P0 is the initial decision parameter and which is 5 by 4 minus R. So, in my previous lecture, I have already discussed how to derive these two equations. Now, I will show you how to find out the point based on the decision parameter. Okay. Now, suppose we want to find out the y coordinate, y value for the k plus 1th iteration. So, at k plus 1th iteration, the x value is x of k plus 1. Okay. So, this x of k plus 1, we can find out from the previous x value. That means we can find out x of k plus 1 by only using addition, only incrementing the previous x value by 1. We can find out the x value for k plus 1th iteration. Now for this x value at k plus 1th iteration, we have to decide what will be the y value, whether the y value will be k or yk minus 1. Now for the k plus 1th iteration, the y value will be designated as yk plus 1. But remember one thing, it is very clear, you should be very careful and you should understand it very carefully, listen, that this y of k plus 1 does not mean, this is not equals to, this is never equals to y of k plus 1. Don't consider like that. So this is very wrong assumption. For the circle generation algorithm, y of k plus 1 doesn't indicate that the value is yk plus 1. Y of k plus 1 indicate that y value for the k plus 1th iteration. So the y value for the k plus 1th iteration, as you can see from this figure, that the y value for k plus 1th iteration either can be yk or y of k minus 1. Clear? Again, I am repeating the same thing. You should be very careful that you should understand this, that y of k plus 1 is y value for k plus 1th iteration. But this y value of k plus 1th iteration is not equals to yk plus 1. This y value of k plus 1th iteration will be either yk or yk minus 1. So here, these k plus 1 indicate the iteration number. This not indicate the y value for a particular x. Clear? So I think it is clear to you. Now, what we will do? So, at k plus 1th iteration, so at k plus 1th iteration, what we know? We know the p of k plus 1. Okay. So for k plus 1th iteration, if I want to find out the if I want to find out the y value for k plus 1th iteration, I have to compute this p of k plus 1 from the previous iteration. So this is my kth iteration where I, based on the value of pk, we will take the decision which pixel should be illuminated. Along with that, here also we will compute the p decision parameter for the k plus 1th iteration. So being at kth iteration, we will compute two things. One is the xy coordinate for the kth iteration, and along with that we will compute the decision parameter for the k plus 1th iteration. Clear? Now this p of k plus 1, this decision parameter is used to compute, to find out what will be the y value. Now as you know that here we can find out by using this equation, we can find out the p of k plus 1. Now if the value of p of k plus 1 is less than 0, means this midpoint is inside the circle. That means we have to consider the red curve. So you can see a curve drawn by red color. So we have to consider the red curve. So that means the decision parameter is less than 0, means that midpoint is inside the circle. So if it is inside the circle, if I consider the k minus 1, that means if I consider, in that case, if I consider the y value is y of k minus 1, in that case, we are pushing the y value again towards the inside of the circle. Again, try to understand that if for the decision parameter p of k plus 1, if it is less than 0, and for that decision parameter, if I consider the y value is k minus 1, that indicate we are considering a point which is inside the circle. But what is our objective? Our objective is try to find out a point, try to find out a pixel which is on the circle. So if I consider y of k minus 1, then that means we are choosing a point which is inside the circle. So in that case, what we have to do? We have to, instead of choosing y of k minus 1, if for p of k plus 1 less than 0, we have to consider the y value as yk. Similarly, if the decision parameter is greater than 0, in that case, greater than 0 means the midpoint is outside of the circle. So if you consider the y value is yk, that means your y point, your y coordinate will go far away from the curve. So in that case, so that will not give you the good result. In that case, you have to consider y of k minus 1. So fine, clear? So again, so here you can see that for if p of k plus 1 is less than 0, in that case we have to consider the y value as yk. Otherwise, we have to consider the y value as yk minus 1. Okay. And if it is equals to 0, that means this y is an integer value. And we have to consider that integer one. So if p of k plus 1 is equals to 0, that means we are getting a point on the circle, and that indicate the midpoint is on the circle. Then we have to consider the midpoint, and definitely in that case it will be integer one. Now, what we will do over here? So I think up to this it is clear. Now we will write down the algorithm for the midpoint circle generation technique. Okay. So I am writing the algorithm. Please check. So this is the algorithm for midpoint circle generation. Midpoint circle generation technique. We are writing the algorithm for the midpoint circle generation. So here you see for the step 1. So in the step 1, we have to take the input. And what are the inputs we have to take? The radius r and the center point xc, y. And here we can consider the starting point x0, y0 is nothing but 0, r. Now, in the next step, that is in step 2, we have to find out the initial decision parameter P0, which is nothing but 5/4 minus r. Okay. Now, in the third step, we have to find out the x coordinate and the corresponding y coordinate for each iteration. Now, if, as I discussed just now, if consider k is my iteration, if p of k is less than 0, fine. So if it is less than 0, then the point is, next point is, midpoint is inside the circle. That means we have to choose a point which is outside. Okay. That means we have to choose a y value which will push the points rather towards the perimeter of the circle. Okay. So in that case, if p of k less than 0, that means the next x point will be x of k plus 1 and the y value will be yk. Okay. The same for all. Along with that, so if it is so, we have to compute the p of k plus 1 in the same iteration. And what we have to compute, how we can compute the p of k plus 1? To compute the p of k plus 1, we have to follow this equation. Okay. So p of k plus 1 is equals to pk. Now, what will be the y coordinate for this particular iteration? So for this particular iteration, the y coordinate will be yk. Clear? The y coordinate is yk. So if the y coordinate is yk, that means it will be p of k plus, so I will replace this y of k plus 1 by yk. So it will be y square k minus y square k. It gets cancelled, and this will also yk minus yk, again it will get cancelled. So what we will get? We will get that p of k 2 into xk plus 1, okay, plus 1. I think it is, you can understand, you just check it. What I have done, I replaced, that means the k plus 1 is iteration. So I replaced the y of k plus 1 by yk. Okay. I replace the y of k plus 1 by yk. So these two terms get cancelled. So it now becomes pk plus 2 of xk plus 1 plus 1. Now xk plus 1 is nothing but pk 2 of xk of plus 1. You can consider it like that. So whatever I can compute the decision parameter for k plus 1 is iteration. Otherwise, that means if If P of k is greater than 0, if it is not less than 0, that means we have to consider the y value as yk minus 1. Okay. So otherwise, the next point we have to consider is nothing but x of k plus 1 and the y value will be y of k minus 1. So if you choose the y value like this, then based on this y value, we have to compute the decision parameter p of k plus 1. So the decision parameter p of k plus 1 is nothing but p of k 2 into, I can write xk plus 1 as I got it from this equation. So let us name it by equation 1. So from the equation 1, I got that p of k is equals to 2 of xk plus 1 plus. Now, what is the yk? Yk plus 1? Yk plus 1 is nothing but y of k minus 1. Okay. So if you replace it by y of k minus 1, so it will be yk minus 1 whole square. That means the equation will be yk square minus 2yk plus 1. So let me write it. I will derive it for you. So what we should write? We should write this y of k minus 1 square minus y of k square plus, sorry, it will be minus y of k minus 1 minus yk and then plus 1. And as you know that y of k minus 1, so y of, as you know that y of k minus 1, we can write it like that, yk minus 1. Now we got the point. So by replacing all, I can get 2 of xk plus 1. I will write it like that. That means xk plus xk. Then with the value of xk, I am adding plus 1. That means the x value for k plus 1 is iteration. So that I can write like that. Plus, so here you can write y of k minus 1 whole square minus yk square minus yk minus 1 minus yk and then plus 1. Okay. So if you write so, what will happen? If you derive it, you will get p of k plus 2x k plus 1 plus it will be yk square minus 2yk plus 1 minus y square k minus, so these two term gets cancelled. So this two term gets cancelled, this yk and y minus yk plus yk. So it will be, this is minus 1. So it will be plus 1, then plus 1. So I think it is clear now. Just check it. So after doing all those things, what we can write, these two terms get cancelled. Right? So I can write it k plus 2 of x k plus 1 minus 2 of yk plus, better I will write it like that, 2 plus 1. Fine. I can write it like that. Why I have written it like it? So you can see in the next step, we will write 2 of xk plus 1. Then I took 2 as common. It will become yk minus 1, yk of k minus 1, then plus 1, which I can write like pk plus 2 of xk plus 1 minus. So what I can write? I am subtracting 1 from the y value of kth iteration. So I can write it yk of minus 1 plus 1. Okay. So in this way, I can compute the decision parameter for k plus 1th iteration. Okay. Now, so this is all about step 3. So in the step 3, either we have to compute a decision parameter like this one. So these two are our final equation. You don't need, while you are writing your algorithm, you don't need to go for all the derivation. While you are writing your code, you don't need to go for all the derivation. You will directly use these two equations. Fine. Now, in the next step, that means in our step 4, that previous was step 3. So in the step 4, we determine the symmetric point for other 7 octets. So what we have to do? We have to determine the symmetric points for other 7 octets. So as I told you, as I discussed earlier, so in this way, suppose if xk plus 1 and y of k plus 1, again I'm just telling you once more, this y of k plus 1 is not the y value for k plus 1, fine? So y of k plus 1 means that y value at k plus 1th iteration. It may be yk or it may be yk minus 1. Fine. So whatever. So we will compute the points on the perimeter of the circle. So these points belongs to octant 1. So if you can see the circle which we will draw. So this is our circle, and consider this circle is divided into some octant. So and those octants are, so this is our octant 1, this is octant 2, octant 3, octant 4, octant 5, octant 6, 7 and 8. So what we will do, we will compute the next point. So this is our point P1. So consider this point P1 is nothing but x of k plus 1 and the corresponding y value. It may be yk, it may be yk minus 1. Okay. So if it is xk plus 1 and yk plus 1, then in this octant, that means in the same, for the octant 1, if the point is P1, in the same quadrant for the octant 2, this point will be just reverse. So it will be y of k plus 1 and x of k plus 1. Okay. Now, as I got these 2 points, definitely I can compute this one. this is the mirror image. So if it is the mirror image, so in this case, so here the x value is minus and y value is plus. So what is the point? P1, point P1 is xk plus 1, y of k plus 1. So here the points will be like that. So in this case, the point will be minus of xk plus 1. So better I should rename it. This is P1, this is P2. Say it is P3. So the point P3 will be minus of xk plus 1 comma yk plus 1. So if it is P3, then the next point here, it is just the mirror image. It will be, let's say it is P4. So the point P4 will be, it is yk plus 1. So it will be minus of yk plus 1 and this is xk plus 1. Okay. Now, again, with respect to x-axis, all the points P1, P2, P3, P4 are the mirror image. So here, this point, we can say this is P1 dashed. This point is nothing but P3 dashed. Okay. This point is nothing but P2 dashed. And this point is nothing but P4 dashed. Clear? So what we can do? We can compute all the other points. So what will be our P2 dash? P2 dash is just the mirror image of the P2 with respect to x-axis. So here you know the x value will be plus and y value will be minus. So here the point will be y of k plus 1 comma minus x of k plus 1. Similarly, if you consider the P1 dashed is the mirror image of the P1 with respect to x-axis. So this value will be x of k plus 1 minus y of k plus 1. And P2 dashed is the P3, sorry, this is P3. So P3 dashed is the mirror image of this P3. So what we can write? We can write P3 is nothing but, so what is P3 over here? The P3 is minus xk plus 1. So in this quadrant, all the points are negative. X value is also negative. Y value is also negative because this is the origin. This point is 0, 0. The center is at the origin. So here I can say that the value of P3 is minus xk plus 1. So what we should write? We should write it minus of xk plus 1 comma minus of yk plus 1. And similarly, what will be the value for P4 dashed? The value of the P4 dashed is just the mirror image of P4 with respect to x-axis. So what is the P4? The coordinate for the P4 is minus yk plus 1. So it will still remain as minus yk plus 1 and the x value will be minus of xk plus 1. Okay. So those are the 8 points which I can generate based on the single point. So we will follow the same logic over here. So what we have to do? Determine the symmetric point for other 7 octants. And what will be the points? The points, if the points on the octant 1 is xk plus 1 and yk plus 1, then the other points, that means the points for the other 7 octants will be like it one. The point will be either yk plus 1, x of k plus 1, fine, and then another points will be, and now we will find out all the mirror images. So the points will be like minus of xk plus 1 minus of yk plus 1. First let me compute the other points. Y of k plus 1 minus xk plus 1, y of k plus 1. This is the points for the this coordinate, that means for the octant 3. And then minus of yk plus 1 and xk plus 1. Then we have to compute the points y of k plus 1 minus x of k plus 1, then minus y of k plus 1 minus x of k plus 1, then minus x of k plus 1 minus y of k plus 1, and the last point is this one, this point P3, which is minus xk plus 1 and plus yk plus 1. So that I have already written. So sorry, it will be this P3 dash. Okay, so this point. So I missed xk plus 1, yk plus 1, this one minus xk plus 1, yk plus 1 minus yk plus 1, xk, yk. So 3, 3, 6, 7. And which one is left? This yk plus 1, xk plus 1 minus xk plus 1, yk. So 7, 8. So here all the 8 points are there. I missed someone. So you can check. This one is I missed this point. So I have to write it like that. So x of k plus 1 and minus y of k plus 1. Fine. So in this way, you have to generate all the points on the octet. So based on the single points, once I can calculate the 1 point, I can calculate all the remaining points on the circle. Fine. Now, step 5. So whatever the calculations we have done so far, all the calculation, you can remember, you can see one thing in all my calculation, the center of the circle is at the origin. But actually, we want to draw the circle in anywhere else where the center may not be origin. So in that case, what we have to do? We have to shift all these points with respect to the center. So you can see at the first step, we took the center point xc and yc, but all the calculation we have done based on the considering the center at 0, 0, that means at the origin. So now what we have to do, we have to shift all points with respect to xc, yc, which are the center. And how we can shift? It is very easy. Take all the points and add them with the xc. That means for the first point, I am showing you for the first points. So you can do rest of the things. So xc, this one, and the next point will be like this one. So if I shift it, it will be xc plus xk plus 1, and the next point will be yc plus y of k plus 1. Fine. So in this way, you just add xc with all the points. Then in that, and if after adding it, all the points on the circle will be shifted with respect to the center. And so how far we have to, how many times we have to repeat all those things? So in the step 6, we have to write down. You have to write down. Repeat step 3 through step 5 until x is greater than equals to y. Now what is x? The x is this part and this y is this part. So until this x value is greater than equals to y, we have to repeat it. And why it is so? Because you can see in the circle, why I am moving like that. So up so far on this point, as this point is passing through the origin, as this line is passing through the origin, on this point the x value and y value will be same. And after that, you can see, if you consider the arc here on this arc, the x value should be is greater than the y value. But before that point, before the point on the line which is passing through the origin, before that, all the x value is less than y value. But after that, while x will be x equals to y, that means while the point is on the line which is passing through the origin, after that point all the x value will be greater than y. So that means we will shift from, we have computed, so if x is less than equals to y, that indicate and if x is equals to y, so that indicate we have completed all computation of all points for the octant one. So that means we don't need to compute further, so we have to stop. So this is all about the algorithm of the midpoint circle generation technique. Okay. Now I will show you a very simple example, a problem. So you can see, you can consider a problem. I will show you that a circle where the radius, so this is a problem. I should write it. This is the mathematical problem. Consider the radius of a circle is 10 and the center point is 0, 0. Okay, and it is 10 and xc is equals to 0 and yc is also 0. Okay. Now, okay, another thing I just forget to mention that in the step 5, you will shift all the points with respect to x coordinate and y coordinate. But those new xy, okay, those new xy will not be used to compute the point decision parameter of pk plus 1. The decision parameter will be calculated based on the x value and y value which we got in the step 4. Step 5 is only used for the plotting purpose. The x value and y value which will got, so that x value after shifting with respect to origin, with respect to center of the circle, those x value and y value is will be only used for the plotting purpose. It will not be used for to draw the, to find out the decision parameter in the for the next iteration. Okay, so here my x coordinate center of the circle is 0, 0. That means x is equals to 0 and y is equals to 0. So what we have to do, we have to compute the p0, that means the initial decision parameter, and which is nothing but 5 by 4 minus r. So for your computation purpose, what you can do, you can write it 5 by 4 as 1, so you can take it as 1 minus r. Okay, so this decision parameter will be 1 minus 10 and which is nothing but minus 9. So what is my p0? My p0 is minus 9. So 5 by 4, again I am repeating, you don't get confused. This 5 by 4 is some computation, the floating point you will get. So for our easy computation purpose, we consider it that 5 by 4 equals to 1 minus r. You can do so. Now, what we will do, so you can see that if you observe this equation, there are, this is 2x, 2y, so it is just like that. Okay, so what we will do, we will always compute the 2x0 which is 0. We will also compute the 2y0 which is also 0. Sorry, not 0. Here the, what is my y0? Before that I should write it, otherwise you can understand. So which is my initial point, which is my initial x0, y0? x0 will be 0 and y0 will be 10 because r is 10. So if so, then what will be my 2x0? 2x0 is 0 and what is my 2y0? 2y0 is 20. Fine. Now what we will do? We will write down a table. So here we can write where is k is my iteration number, pk is the decision parameter, and xk plus 1 and yk plus 1 is the x value and y value for the circle. Then we compute the xk plus 2 of xk plus 1. Then we will compute the 2 of yk plus 1. And why we are computing so? Because for our easy calculation purpose, if you observe the equation for the decision parameter, all the x value will be multiplied by 2 and y values are multiplying by 2. So that's why we, for our easy computation purpose, we are doing so. So those are the different parameters we will compute. Now here, initially the k is 0, 0th iteration. So P0 is -9. As you can see, we have computed from here. So what will my x value? X is xk plus 1 and yk plus 1. Now the x value will be incremented by 1. This is fine. Now what will be the y value? So here see the decision parameter is less than 0. So if the decision parameter is less than 0, that means the point is inside the midpoint is inside the circle. And if the midpoint is inside the circle, we have to push the points towards the boundary. And as we are pushing the points towards the boundary, we have to consider the y as the next y value. So here we will consider, so here the yk plus 1 will be 10. So now this xk plus 1 is 1 and yk plus 1 is 10. So what will be the 2xk plus 1 and 2yk? So this will be 2 and this will be 20. Now this, as we are considering that y value is, the y value for the next iteration is y. So which decision parameter now we have to compute? We have to compute this one. So this is the, in using this equation we will compute the next decision parameter, because as we consider the y value is, sorry, not this one. So as we consider this one, we have to compute this one as the pk is less than 0. So for the pk less than 0, the next decision parameter will be computed by following this equation. So if you use this equation, so using that equation you can see that by following this equation, what we can do, we can write that at the next iteration for k equals to 1, and if I follow this equation pk plus equals to this one, pk plus 2xk plus 1 plus 1, we got the decision parameter pk minus 6. You can compute it, you can check it. Okay. Now again it is less than 0. Y will be incremented by 1, but s will be y will be, when x will be incremented by 1. So sorry, this will be 2, but y will remain same. So it will be 210. So now again we have to compute, it is 4 and this will be 20. So now again, based on the previous equation, we have to compute the next decision parameter. So the next decision parameter at the second iteration, it will be computed from this one, because here the pk is less than 0. So we will follow this equation to compute the decision parameter. So it is pk plus 2xk plus 1 plus 1. So pk is minus 6, 2xk plus 1 is 4. So minus 6 plus 4 is minus 2 and then plus 1. Okay, so it will be minus 1. So at the second iteration, the decision parameter will be minus 1. I think if you put the value, you can calculate it. So minus 1 is less than 0. That means it will be 3 and the y value will remain same, and then it will be 6 and it will be 20. Now after that, again you have to compute the decision parameter. Okay. So if you compute the decision parameter further, so you can compute it at the third iteration. So in the third iteration, how it is computed? The same pk plus 1, that is the minus 1 plus 12 minus 1. Can see the equation again, minus 1 plus 12 plus 1. So minus 1 plus 12 plus 1 means only what will happen? Sorry, minus 1 plus 6 plus 1. So 2xk plus 1 is 6. So minus 1 plus 6 plus 1 means that the third iteration, the decision parameter will be 6. Okay. So now it is greater than 0. If it is greater than 0, x will be incremented by 1, x will be 4, but y will be decremented by 1. So y will be 9. And here it will be 8 and it will be 18. Now in the next iteration, that means in the fourth iteration, again I have to compute the decision parameter. So here how we can compute? Here you can see the value of pk is greater than 0. So if it is greater than 0, I have to use this second equation, this one. I have to use this equation. So it is pk plus 2 xk plus 1 minus 2 yk minus 1 plus 1. Okay. So pk is 6 plus 8 minus 18 plus 1. So 8 plus 8, if you put it, so it will be 6, 8 minus 18 plus 1. So if you calculate, it will become minus 3. Okay. So minus 3. Minus 3 means again negative. Negative means x will be incremented by 1, but y will remain as it is. Fine. So it will be 10 and it will be 18. Now in the fifth iteration, again I have to compute the decision parameter based on the previous value. So here pk is less than 0. So how we can compute? Following the previous equation. So previous equation means this one, pk plus 2 xk plus 1 plus 1. So here minus 3 plus 10 plus 1. That means minus 3 plus 10 is 7 plus 1. So it will be 8. Okay. So it will be 8 means again 8 is greater than 0. So if it is greater than 0, that means I have to increase the x value by 1 and y, I have to decrease the y value. So it will be 6, 8. Now we will compute this 12 and it will be 16. Now based on this, as the pk is greater than 0, so I have to compute the next decision parameter based on the second equation. So in my sixth iteration, the decision parameter, if you compute based on the second iteration, you can get the decision parameter 5. So if it is 5, that means again greater than 0. Greater than 0 means x will be incremented by 1, so it will be 7. And y will be decremented by 1, so y will be 7. Fine. And it will be 14, 14. Now you can see how far we have to proceed. We have to proceed until x is less than y. So here x is equals to y. So 7 is equals to 7. So I have to stop. So those are the points we got. So those are the points on the perimeter, on the arc of the circle for the first octant. Now as you got the points on the first octant, by then based on the equations you can find out the points for the rest of the octants. Okay. So as you got the points for the rest of the octant, then easily you can compute the entire circle. By plotting the points, you can compute the entire circle. So that is all about the midpoint circle generation algorithm. Fine. So far we have discussed this midpoint circle generation algorithm. I shown you how to write down the algorithm based on this decision parameter. And after writing the algorithm, I discussed a problem and I shown you how to compute the decision parameter, and based on the decision parameter, how we can compute the points on the circle. So I think it is clear to you. And thank you for watching my video. Thank you all.